Okay, so we are going to discuss shape, center, and variability today, tied into what we're learning in this chapter. In this first big section, we are going to have a probability distribution, which remember just shows all of the different values of the discrete random variable. This is that APGAR test. This is the same information from the notes last time. Last time you guys found this one. This one was missing. What's the probability that a baby scores a 0 on the APGAR scale? And you were able to calculate that. Well, today all of the information is there, but I'm concerned today with you being able to look at a histogram of this data and describe its shape. So it says underneath there, we can display the probability distribution in a histogram. Remember, this is what a histogram looks like. It's like a bar graph, but all the bars are touching. You're going to have to draw some of these for your homework, and we'll practice that in a second, but just stare at this, okay? When you're drawing one of these, it says the values of the variable go on the horizontal axis. In other words, the top row, all of the capital X values, all the APGAR scores in this case, go on the horizontal axis, 0 to 10. There's a bar for each of those values. The height of each bar gives the probability. Oh, but I skipped over this. The probabilities go on the vertical axis. So you can see that right here. Probability is always a number between what and what? 0 and 1, right? But this time on the APGAR thing, I didn't have to go all the way up to 1 whole because I just glanced across here at all these decimals, and going up to 0.5 was enough to cover all of my bases. So just kind of scan and see how tall your vertical axis needs to be, because we're going to practice drawing one of these at the bottom of the page. All right, let's talk about shape. Way back in the day, we talked about things like, is it symmetric? Is it like that bell shape? Or is it skewed? And this one is skewed. You can see that if I kind of drew a curve over these bars of the histogram, that there's this tail trailing off to the left. So we say that this distribution is skewed to the left. You can say left skewed, skewed left, whatever your preference. And we're going to tack something else on there just to be a little more descriptive. It has a single peak. Just look at the highest bar. It peaks one single time, and right there, that's the single peak. What APGAR score is that? 9. So with a single peak at an APGAR score of 9. That's all you have to do to describe shape. Tell me if it's skewed left or right. You may even tell me that it's symmetric, roughly symmetric, and then tell me where the peaks are, okay? So we're going to do that right now. Down here at the bottom of the page on this example, we're going to draw a histogram to go with this probability distribution. But let's quickly read what this problem is about. Pete's Jeep Tours offers a popular half-day trip. There have to be at least 2 passengers to go on the trip. The vehicle will hold up to 6. So this guy can take 2 to 6 people on his Jeep. He charges $150 a passenger. Let C be the total amount of money that Pete collects on a randomly selected trip. The probability distribution is given. Make a histogram and describe the shape. Okay, that's pretty straightforward. So we're going to take this data, we're going to make a histogram. And so the first thing you're going to do is draw a horizontal axis at the bottom of your page. And the total money collected, that top row of the table, that's what you would put on the horizontal axis. So you just need to make 1, 2, 3, 4, 5 little tick marks. I got a little carried away with my axis there. And those are going to be labeled $300. That's if 2 people go on the trip. $450. That's if 3 people go. $600 he'll make if 4 people go. $750 if 5 people go. And $900 if all 6 people go on the trip. Not too shabby. Let's go ahead and title. This is total money collected. That's what these values mean. You want to have a nice title there. Now draw a vertical axis. We're going to start at 0. And it looks like I need to go all the way up to 0.35. That's the highest probability. The largest probability is that 4 passengers go, because it's a probability of 0.35. So I'm thinking we could just count by 0.05, 5, 10, 15, 20, 25, 30, 35. So let's see, 5, 10, 15, 20, 25, 30, 35. We're really counting by 500ths. So 0.05, 0.10, 0.15, 0.20, 0.25, 0.30, 0.35, and that covers all of our bases. Go ahead and title it probability. You know you're not going to have to draw a histogram for the test. This is the only example where I'm going to have you do that, and you'll practice it on your homework. But it helps you get used to how to interpret them. If you've drawn them before, then you can navigate around them a little easier. So here we go. We're going to draw our bars. The bar that goes with $300 should go up to 0.15. Now, look how I do that. Don't start at a tick mark. You can just look at the example right above there if you want to. But I'm going to span either side of that $300. Okay? And then I'm going to go up to 0.15. It's like straddling the $300 on either side. And then that's going to be connected to the bar for $450, which goes up to 0.25. And then we're up to 0.35, the highest probability. 0.2. And then there's a pretty tiny small chance that he gets $900 if we randomly selected A and see how much he made. There's only a 5% chance that he made $900 that day. 0.05 is 5%. Now look, you've made the histogram. The whole point is to be able to describe the shape, because it does say that in the directions. This one is mostly symmetrical. So we will say roughly symmetric. It almost has that bell shape to it. Okay, so for shape, roughly symmetric. With a single peak. Where does it peak? How much money? Where is the tallest bar? 600, thank you. It peaks at $600. Okie dokie. Next page. So we just covered shape. You'll use words like symmetric or skewed and tell me where it peaks. Now when you measure center of a discrete random variable, you are going to be talking about the mean, otherwise known as the expected value. If you're asked on the test next week, what's the expected value of X? It just wants you to find the mean. Way back in Unit 1, we used mean and median to describe the center of a distribution. But I'm only having you write the word mean because that's the one we use to describe the center of discrete random variables. Median is not what we use. Okay, the symbol for mean is mu. What I'm going to show you now is how to take a table like in that Jeep tour problem that we just had, to be able to take a table that shows you the values and the probability, and I'm going to show you how to calculate mean. Well, I'm a math teacher, so of course I'm going to show you the long way to do it by hand, and then I'm going to show you how to do it in the calculator. So let's look at this one. Actually, we're going to skip this one and come back to it. Turn the page. I want to actually start with the APGAR one. APGAR scores again. Here are the values, here are the probabilities. It says calculate and interpret the expected value. Stay with me. That's asking you to find the mean. Here is how you do this. You're going to have to watch me. Look at the screen. You're going to take the value and multiply it by the probability that goes with it. So I'll do 0 times 0.001. I'm going to multiply those together. Multiply. And then I'm going to add that to the next pair being multiplied together. 1 times 0.006. And I'm going to add that to the next pair value and its probability being multiplied together. Oops, that should say multiply, not add. Multiply, and so forth and so forth and so forth. So you take the value, multiply it by its probability, and then you're going to add those together. Look, you guys, that's what it says on the previous page right here. I just didn't really point that out to you because I knew a lot of you would just like go cross-eyed if you looked at that. But that's all this is saying. Take the value and its probability, multiply them together, and add it to the product of the next one. Now this is a lot of stuff in this APGAR. So here is how you can show your work if you don't want to write out every single one. Write this. We are finding the expected value or the average or the mean or the mu of x. That's why there's a little x in the subscript. So let's show a little bit of work at least. And that would be open parentheses. I'm going to take 0, the 0 APGAR, and multiply it by its probability. And then I'm going to take that and add it to open parentheses 1 APGAR score of 1 times its probability. And then it's really okay with me if you want to just put a dot, 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 indicating that we would keep going and keep going and keep going. Now I am going to make you do this on the calculator, but I don't really care if you write it all down. And at the very end, we'll end with adding the APGAR score of 10 multiplied by its probability. Now I do want you to take a second and figure this out. Be really careful as you move along in your calculator because one tiny mistake and you could end up getting the wrong answer. This is the only time you're going to have to do it this way, and then I'll show you how to do it faster, but actually try it. It's really not that bad, it's just tedious. You should be interacting with your calculator. As you're typing this in, big picture here, we are finding the mean. You should know that that means we're finding the average. We're finding the average APGAR score of a randomly selected newborn. If many, 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 many newborns are randomly selected, their average APGAR score is what you're about to find. Does anybody have it yet and they want to share? 8.128. If you need a couple of seconds to finish up just to verify, that's fine. But if you take all the values, multiply them by their probabilities, and add all of those together, you get an average APGAR score of 8.128. So you are finding the average of a discrete random variable. Now, the interpret part is where some of you are going to struggle. But again, what this means is, we're going to write it in words. If many, many newborns are randomly selected I'm talking a lot, not just 100 from one specific hospital, but hundreds of thousands from across the whole country that you're interested in doing this research on. If a lot of newborns are randomly selected, their average APGAR score, the mean, the average APGAR score, is about 8.128, which is really closer to 8 than 9. That's if many, many newborns are randomly selected. That's what you're finding when you're asked to find the expected value of x, the mean of the discrete random variable. To recap, we talked about shape. Now we've talked about center, which is the mean. And the last thing that we're going to talk about is variability, which is the standard deviation of a discrete random variable. Listen really closely. When you use mean for center, that automatically means you use standard deviation if you're asked about variability. They're like cousins. They go together. If mean is how you describe center, and it is with a discrete random variable, that's what we just did, that automatically means if I ask you about variability, you're not going to tell me about the range or the IQR or anything of that weird old stuff. You're going to talk about standard deviation, which again is this symbol here. That's going to describe variability. Well, here's a formula on how to find it. Do you guys want to use that? Does that look fun? Going to plug into that? No, you don't want to use that? Would you rather get a calculator shortcut? All right, then here's how you're going to do it. Make a note in that blank space down there. You're going to enter your data into list 1 and list 2 of your calculator. Don't worry, I'll make sure you remember how to do all this, okay? So if you have a problem on your test and there's a big table of values, enter the data into list 1 and list 2, and then you're going to hit stat. You're going to arrow over to the calc for calculate, and you want it to calculate one var stats. One variable statistics is what that represents. Just make sure that you have list 1 and list 2 on that next screen. Some of you may not, so that might be a time where I say pause and I can walk around and help you if you need it. So it's really easy. Once you've done it one time, it's probably going to stick because you guys are good with technology. So I'm going to tell you once again, if you don't want to use this really cool formula right here, where you have to subtract and then square and then multiply and then add and then take the square root, then you need to know how to do it in the calculator. Let's try it. Turn the page. Last page of notes. Here's that same exact problem that we just saw. Here are the APGAR scores. You should know the answer to A because we found it on example, what was that? We found it on example 4. So we know that this is going to be 8.128, but let me make sure you know how to type all this in the calculator and get that. So here we go. If you are not doing this with me, you will not remember how. So get your calculator in front of you, and here we go. You're going to hit the stat button. Brody, you doing this with me? Stat, Brody, can you hear me?
Yes, ma'am.
Are you doing this with me? Okay. Edit. More than likely, you've got some stuff in these lists from the student that had this calculator before you that you need to clear out. So if you will arrow up to like list 1 and have it highlighted and hit clear enter, it'll clear out the whole list. So you don't have to go one at a time and delete, 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 delete. If you have stuff in list 2, go up and highlight list 2 and hit clear enter and have a blank slate. Now listen, somebody last period, she panicked because she didn't have L1 and L2. She had L3, L4, L5, Do any of you have that? Raise your hand. Yeah, it was the person sitting in that spot. So it's okay. You can just leave it alone and I'll help you. Yeah, it'll still work. So that really doesn't matter. Okay, list 1 on the APGAR problem is going to be all the different values that a baby can get for an APGAR. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or a 10. And then carefully, it's not a race, you need to be very accurate. If you mess up here, you're going to mess up your whole answer, okay? Go back and list 2 and type in the corresponding probabilities. But just go slow enough and double check as you go. I say that because you guys, I always mess up. Because I'm trying to talk while I type. And then you may want to just kind of peruse through there, make sure you've got them all correct before you calculate anything. There are calculator apps for your phone that do the same stuff, so don't feel tied to these yellow calculators for your homework or anything. Okay, once you have the table of values entered in, here is how you're going to answer the questions. Find the mu and the standard deviation. Hit stat again. Arrow over to the calculate menu. We did this last semester, by the way. This is not brand new information for you. And we are interested in one variable statistics. Here is the screen, though, that you need to make sure that you've got list 1 and list 2. Sydney, you'll do list 3 and list 4. Okay? But listen, you guys, if one of those is missing, it's no sweat. Here's how you tell your calculator, oh, I want list 2 right there. Right here in blue, your calculator says list. So if you hit second stat, it'll say, okay, what list do you want? Well, in the spreadsheet that we made, we want list 2, so choose that one. You have to have both of them in there. Think of it this way, you enter data into 2 columns, so you need those 2 columns on this screen. When you've got that, just hit calculate, and your answers are right here on the screen. I just need to make sure you know how to read these answers. Mu is kind of interchangeable with X bar. So this X bar at the top, that means the same thing. That's the expected value, that's the mean. And that's the answer that we already got when we did it by hand. But tell yourself this. When it says to find mu of X, that's the same thing as what your calculator is calling X bar. And that's the 8.128 at the top of your screen. I'm not going to make you interpret that because we just did that on the previous page. That's if many, many newborns are randomly selected, their average APGAR score is about 8.128. Right here, this answer is also on your screen. Calculate and interpret the standard deviation. Here it is right here. 1 point, let's take that out to the thousandths, 1.437. The standard deviation of the discrete random variable is 1.437. The interpret piece, some of you are going to struggle with, but here's how you would write this. Here's what standard deviation means. It's kind of a tough concept to wrap your mind around, okay? It's basically like the average distance away from the average score that babies' APGAR scores are. It's just really weird. Here's how you write it in words. If many, many newborns are randomly selected, that sounds familiar. If many, many newborns are randomly selected, their APGAR scores, here's the key phrase that you can like copy and paste, will typically vary from the mean Varying from the mean means how far away you are from that average, by about 1.437. Now, I know that's a really abstract thing to wrap your mind around. I won't ask you to do that on a test. So if you can get the answer on your calculator, that's success. If you can then tell me what the heck it means in words, that's like even better. But it's okay if you can't. The good news is you can copy and paste this. Like on the next one, we're going to write, if many blank are randomly selected, their blank will typically vary from the mean by about blank. It's literally going to be word for word the same. So on your homework, if you're wondering what the heck to write, you can use this as your template. So let's do one more and we'll be done with the notes. Indiana University Bloomington posts the grade distributions for its courses online. Suppose we choose a student at random from a recent semester of the university's business statistics course. So specifically, that's who we're looking at. Students in the business stats course. The student's grade on a 4-point scale, think of it like a GPA. A is a 4. Is a random variable X. And here's the probability distribution. So here are the different values. They're discrete. So a student can either have a 0, a 1, a 2, a 3, or a 4. Okay? Here's the probability that a randomly chosen student from this college's business stats course has a grade of a 0, like an F. Here is the probability. It looks like most students actually are doing really well and they have an A because they have the highest probability comes from there. So that's what's going on. All we're going to do is we're going to put this in the calculator, and I know that because it says to calculate the mean and calculate the standard deviation. And then at the end, we'll go back and do the interpret part. So 6 out of the 14 test questions next week are, hey, here's a table. Can you type this in the calculator and tell me the mean and tell me the standard deviation? So this will be a very easy test. All right, here we go. Calculator. Stat. Edit. Clear out all the old stuff. This is nice because it's a lot shorter than the APGAR problem. 0, 1, 2, 3, or 4. That's it. Thank goodness. 0.011, 0.032, 0.138, 0.362, and 0.457. And double check that everything is good. Okay. And then stat, calculate one variable statistics, list 1, list 2. Yay. Cool. We've got our answers to both right here on the same screen. X bar is what number 1 is asking for, 3.2. What that means is if many students were chosen at random, let's just put students are randomly selected. That way it sounds just like the newborn one. If many students are randomly selected, think about what you just found. You found the average. Their average grade would be about 3.2. Number 2, the standard deviation of the discrete random variable is right here, 0.88. If you're still kind of fuzzy on standard deviation, copy and paste that newborn thing that you've got right above there, but swap out the words for the words that make sense in this problem. If many students are randomly selected, their, well, we're not talking about APGAR scores, we're talking about their grades. Their grades will typically vary from the mean. This is how far away their scores are from the mean grade on average. By about 0.88. That's what that means. That's the interpret piece. Again, if you're able to get the decimals, then you're going to do great on the test. AP students down the hallway, they learn the same stuff, but when they take the AP's test, they not only have to calculate things by hand and use those crazy formulas that we avoid, but they also have to be writing those paragraphs correctly. But you guys, you should feel proud of yourselves because you're doing the same math they are. Okay? Now you do have a homework assignment that goes with this.